Hey, Mr. Blaze, I think you're muted.
Okay, hello. Can you hear me now?
Yes, you can get enough.
Hello, guys. Can you hear me?
Loud and clear.
Okay, awesome. Okay, so I was talking about the objective for today. These are the objectives right here. So this is going to take us for today and tomorrow. So for today, we're going to focus on the last two derived tables and common table expressions. Right. So I will begin with derived tables. It's kind of linked to what we did in subqueries. It's basically a subquery, but then when you put the subquery in the from clause, it becomes a derived table. So SQL Server gives this a different name. So if you identify, this is the syntax of a derived table right here, and this is the one for a CTE. CTEs they always begin with this with keyword. So we're going to look at the simple one first. This one, simple in the sense that it's tied to the concept of a subquery. So you build an inner query, which is right here, give it a set of parentheses, give it an alias. This is very important. So this statement runs and generates a table. Of course, you understand that column 1, column 2, they're going to be part of a table. Now, this is the name of the table. Now, we can then go above and write an outer query. This is the parent query, which is selecting data from that table. You see that? All right, this is very, very important. So this is powerful in the sense that you may have a logic you apply in the inner query, you fetch data, and then you want to apply extra logic to the data you've captured in the child query. This is very important. This generates a table. All right, this is a special kind of subquery. It actually generates a table. All right, and this is the name of the table. It is a virtual table. The table is not stored in SQL Server Object Explorer. See, you're not going to find it there. So this is us retrieving data from a query. Select star from a query. And this is the query right here. This query runs and generates this name. You see, it's stored under this name. This is very important. All right, and finally, we'll be able to solve that Uber example where we ask you to find the third ride of each Uber rider. All right, so we're gonna classify the rides 1, 2, 3 for each Uber rider or Uber user, and then we're gonna go outside in an outer query and put a condition to get just the third ride of each user. This is very, very powerful. So usually you capture data. You don't want to mess with the data you've captured. You go outside of that environment to apply further logic on what you've captured. This is so powerful, right? And I just talked about a post on LinkedIn. Somebody posted this, right? And they were asking if you're a team CTE or a team subquery, right? And this is the post right here. And this is the same thing you see right here. I'm going to share this with you all. So my goal is to expose you to a lot of these concepts so that you can, be armed with enough resources to target questions. Right. So always remember this: you can capture data which meets a set of criteria, and then you go outside and apply further logic on what you've captured. Right. Instead of investing all the logic inside one query and making it more complicated to read. So first capture the data and then go outside and expand the analysis. So that's what we're going to see first. Let me see if I have the, where can we begin? So let's look at, we are beginning with derived tables. Let's look at this one first. SQL with day one, derived tables. Let's target that file and open. That's the first file we're going to begin. So let's focus on this so we can understand this concept, right? So week 8, day 1, we are beginning with this right here, derived tables and CTEs. I think there's a script we need to execute. Can we all execute this database? TSQL 2012 database script. Yeah, we're gonna need that. So just open and execute as well. Let's just get everything ready. We're gonna come back to the Uber one later on. So let's execute this. Open and execute. There's a script right here. Just execute. This is taking forever to execute. Let me know once it executes at your end. I just want to make sure it's not just an issue with the script.
I executed mine before the class and it
Okay.
executed fine, yeah.
Let's see what's going on. Yeah, my system is too slow. Anyway, I will come back to that. So when we talk about table expressions, these are the 3 key things. Right? Usually these 2 are more popular. Right? So table expressions are named queries. See, all of these queries have a name. So let me just focus on this opening statement right here. Table expressions are named queries. And let me show you that this is the syntax for a derived table. You see, we run the query, the select statement, and we'll give it a name. This is a query, and this is a name. So this is a named query. That's where it begins. So you build the inner query or the subquery, and you give it a name. So this table, this query generates a table, and the data returned by this query is stored in this table. We can now do a select whatever from that table, but then you must show the query, because if you delete the query, this becomes useless. So these are named queries. Now for the CTE, you cannot miss this. It always begins with the keyword with. This is the name we give to this query. See, this is very, you see that environment, this to this. You see, so in a derived table, the query, the subquery or the inner query is placed in the middle. Right here, you see the position. For a CTE, that same query is placed right here, but the name of the query goes above. For a derived table, the name of the inner query is just placed directly after the definition of the query. See? So this is the same. This query runs and generates a table stored right here. And then we now build an outer query. You see, for a CTE, what we have above is actually placed below. All right, so we've captured data above, we've stored it in this table. We now go below to run a statement that fetches the data we've captured. You see, the name right here ties with the name. It must match. So I've captured this data, store it in this, and I'm going below to do this from that data. See, the outer query for this version is below, or the outer query or the parent query in this case is above, right? So these are all named queries. You discover that they are queries that you write and you give them a name. Queries that you write and you give them a name, and then you can now query from that name or what you've captured up, right? So the goal is to keep data temporal storage. Yes, this is true, because when you run this, you store the data right here. It holds it temporarily. There's no physical storage. Physical storage is when you have a folder in this hierarchy which stores it. You see, so it just holds it temporarily, right? So this is a layout. Okay, let's begin. Let me see if this is still running. So first thing you do is you write an inner query that returns a relational result set. So what does it mean? It means that every column in this must have a name. So if I go back right here, for this to be a relational result set, you cannot have a column without a name. This is very important. If you try that in this either derived tables or CTEs, you're going to get an error. So a relational result set is when every column has a name, and also avoid the use of the order by, right? So you build first an inner query, make sure it is relational. Every column must have a name, and then avoid the use of an order by. See, that's the first step. Same is, I'll focus more on this side. We're going to come to this side later on so that I don't confuse you guys. So these are focus, you get this. That is the inner query, right? So that's step one, right? Now name the query, of course. That's step two. This is the query you've built, the inner query. You give it a name. This is it right here. And then what's the third step? Is now query it from above. You bring in now the outer query. This is the outer query. See, so step one, build the inner query. Make sure it's a relational result set. Second, give it a name. The query, these are named queries. The query must have a name. And then write an outer query from above. In the case of a derived table, it's above. In the case of a CTE, it's going to be below. Those are just the three key steps to remember, right? Let's see. We're going to begin with derived tables. This is the syntax of a derived table. It is basically a subquery that is placed in the from clause of an outer query. And anything you place on the from clause, it's what? It's a table, because the from clause is meant to hold tables, right? So this query generates a table, and this is the name of that table. The only thing you need to remember is that this table is not stored in any folder. And that's why we say that this holds data temporarily. See? In the opening statement, we said this table expressions and name queries. The goal is to keep data in temporal storage. Permanent storage is when you run the script and the data is stored in, it could be in a table, it could be in a view, it could be in a stored procedure. That is what we call permanent storage, right? Okay, so let's go ahead. Now, so we're going to begin derived tables, and I wanted us to practice this. So let's just go through what we've done throughout this training. Throughout this training, we started off by writing a query which pulls data from a physical table. And this is an example. So if you just connect to 2012 Adventure Works early 2022, I will need to shut down this script. It's gonna mess stuff. Shut down this one as well. Probably I'm just gonna get a fresh start in this. So while I'm trying to adjust my stuff, can you guys just walk through this process, knowing that we can select data from a physical table? We can also select data from a view. That's a view right there. We can now also select data from a query. This is the new part we're going to study. And I want you guys to practice this. Right. So build this inner query. execute the data return is stored in table 1, and then go outside and do select star from table 1. But what is table 1? So you cannot just put table 1 like this, because table 1 is not defined and stored physically, right? Table 1 is the definition for table 1. So for a start, that's what I want us to explore. I'm going to shut down my management studio. So while I'm doing shutting down, just practice this, and that's the foundation for a derived table. It is basically a subquery. So start by building this subquery, put in a set of parentheses and give it a name, and then go outside and just do select star from what? From this query. And that's the concept of selecting data from a query. So we'll see the three possibilities. You can select data from a table, physical table. You can select data from views, virtual tables, and you can also select data from a query, and that's the foundation of a derived table. This is us doing a select star from. The from carries a query, selecting data from a query. Selecting data from a view, the from carries a view. This is a view. Selecting data from a physical table, the from carries a physical table. And of course, you can join other physical tables or other views. You can join a physical table to a view. You can join a view to a physical table. Right? All those things are allowed, you see. So yeah, go ahead and practice that while I shut this down, and I'm going to launch this for a better performance. Okay, so I'm back. So this is what I wanted us to practice. You can just choose any database. Let's just use AdventureWorks. Okay, I'm just going to go for any table, select star from, let's go to production. So I want to work on this table. So let's me build the inner query. All right, so this is in the context of a derived table. I'm going to just build the inner query. Like, so for a start, let's just keep the inner query to do a select star from that. See, and then give a name to this by putting it in a set of parentheses, and then call this. Just call this. The AS keyword is optional. You can do this. The name you provide right here could be any name. You are in control of this process. So you're just saying that this table right here will run and it will store the data return. This query, sorry, will run to store the data return in this table, T1. And this is what I want you to do now. Just go above and just do a select star. Let's keep everything asterisk for now. From, see, this is the interaction I want you to see. All right. This framework is very important. Before we go any further, do this on any table within a database. Select star in the inner one, put it in a set of parentheses, give it a name, and then go outside and do a select star from that table. And you're going to see that what you've typed is in line with this. This skeleton has to be understood. And usually I prefer to indent so that you see this nicely done. This is very powerful, and this is the basic framework of what we call a derived table. Right? I want everyone to practice this. Practice this a couple of times. This is very, very important so that you get the steps. Step one is this: build the inner query. Step two, give an alias, give a name to the query. So this is the query. This is a name I'm giving as T1. So this query generates this table, and this table gets stored in a table called T1. Then go above and write the parent or the outer query. And of course, you can still continue with a where clause, a group by, a having, just like that. So this is not going to what the parent query. And see, it continues. I want you to have this framework in mind. This is very, very important. This is the foundation of the concept of a derived table. Right. So you have to understand what it's doing. This is actually fetching the data that will be used in the from clause of the outer query. So you can clearly identify this is a subquery. But in this subquery, unlike the others we've seen before, it is actually being placed on the from clause. So the from clause carries what? Tables. In this case, a table is derived from a query, hence the name derived table. You see, in this one right here, the from clause carries a physical table. The name of the table is specified. There's no confusion on this one. But in this outer one, this from is actually targeting a query, right? Since the from clause is built to carry tables, this runs and generates this table called T1. But if we remove the definition of T1, we render it useless, because if we now do select star from T1, T1 is not an available table in the database you're connected to. T1 is built from a query. T1 is a table that is derived from a query, hence the name derived table. So our T1 is a table that's derived from this query. So this gives you a lot of possibilities in solving questions. So some questions you will need to do analysis to extract the data, fetch the data. Like several steps you're going to go through to fetch the data. Once you have that data, you now store it temporarily, and then you go above and do the final and the main analysis. This has helped you to decongest the steps, all right, instead of forcing everything into a single query. And that's the goal of these derived tables. They come in so handy, they're very powerful, right? Right. This is going to be very interesting when we start looking at questions, right? Let me just take another example. So let's go to Global Superstore. In Global Superstore was the major table we have. I think we have the orders table. Let's run this and see. We have this. So you can actually perform. Let's just keep it simple. Let's continue building that framework. This is going to be our inner query. So that's the first step. Build the inner query, and then put it in a set of parentheses. Give it a name, right? And then go outside and build the outer query. Right. But now we're just keeping everything asterisk with no where clause, no logic, so that you can just understand this process. Once you have the mastery of this, we're now going to implement it in problem solving. This is really, really straightforward. Right? This is the inner query, which is placed in a set of parentheses, and then these futures on what? The from clause. So this generates a table called tab1, and this from clause runs against that query. See? Now this tab1 is a table that is derived from a query. Hence that name derived table. This I'm really working so hard so you can understand these dynamics, and this is it right here. Right. So when you have this framework, there's a lot of questions you can solve on this. So now let me go back to the slides. Let's start looking at examples. So we were looking at this right here. I'm going to open that. Okay, so these steps, you have to remember them, right? So you first of all build the inner query. Make sure you're returning a relational result set. I'm going to dismiss this tool. Okay, hopefully this time is going to work. So yes, we've talked about this selecting data from a physical table, views, and the new concept, selecting data from a query. And there's the query right here. It generates this table, and that's a derived table. That's the concept of a derived table. This syntax is very important. Now let's so some result sets are difficult to extract from database without performing multiple queries. So derived tables help with some problems by creating virtual tables within the scope of a query. Right, this is basically the virtual table right here. Right, so this query runs and generates this, stored in this. Now we can go above and select stuff from that. Right, I'm just going to skip. So this is the syntax right here. Same syntax we see right here on this side. Right. Okay. I'm going to skip this. You can practice that later on. I'm going to skip this. Instead of skipping, I'm just going to go ahead and explain. So the goal right here is to, so you can run this because you have this mind. If I want to run this, it's going to take me a long time for it to run. So the goal is to rank products within each product category, starting with the product having the highest unit price, right? So there are different product categories, which is captured by product ID. Oh, sorry, category ID, right? So if you look at what we're doing right here, we're using, this is a ranking question. So we're using a window function called row number. Right, since we want to rank based on each category, so we have to partition the products by what category ID. And since the, of course, you remember this is a window function, the over clause is mandatory. And this is a ranking function, this is a ranking window function, the order by is mandatory. Right, so we are ranking these products based on unit price. That's why we order by unit price descending. So the product with the highest unit price in each category will get row number 1. See? Now, if you notice, we have to just get the highest unit price in each product category. So after ranking, you have to go now to each of the partitions that's partitioned by category ID, and you extract the one with the highest unit price. Right. This will mean, for example, you can put in the where clause where row number equal to 1. This is what we are trying to do right here. But then unfortunately, this right here is a window, it's an alias. See, this is coming from an alias. This is the ranking that has been done, and that column is an alias. This is the column alias right here. This alias cannot be used in the where clause. This is going to give you an error. A column alias cannot be used in the where clause. So that's why you get this error, option 1, using the column alias in the where clause. You cannot use a column alias in the where clause. Column alias are only allowed in the order by. I've explained this previously. You have to know the execution order of the select statement, right? So you're going to get this as an invalid column, right? It's an alias, a column alias. It can only be placed in the where clause. So by ranking each product based on unit price within each category ID, all those that have rank number equal to 1, that is the highest, that is a product with the highest unit price in each category ID. So this was a good strategy, but unfortunately, you cannot use this in the where clause. So what is the second option? Instead of using the alias, we actually use the logic itself. You see, we replace the alias by the logic. This is the alias we use in option 1. Let's replace it with this. This is normally what we do. When aliases don't work, we use the definition of that column. See, this the logic, that's what we call the definition of the column. So we place it in the where clause, but this generates another error. If you remember, window functions cannot be used in the where clause. This is a window function. You cannot use a window function in the where clause. You have to remember this. Right. So when you run this option 2, you will have that error. This is the error. I've copied all the errors. So I give you the option, the strategy in the option, and I give you the error generated. So window functions can only appear in the select or the order by. We are trying to use a window function right here on the where clause. Option 2 gives you an error. And now you become frustrated. It's a simple question, simple problem, simple strategy. Right. So in this case, don't panic. Just remember this strategy. What you've currently built with a ranking, that will constitute your inner query. Now, once you go to the outer query, all your column aliases in the inner query become full-fledged columns in this table. They are no longer aliases. So when you go outside that environment, the aliases you had inside this environment are no longer aliases. They are now full-fledged columns that are part of this table. Right? So you can now use that column in the where clause of the parent or the outer query. And this is a strategy that a lot of analysts use. See, you can read this conclusion. And now what is the solution? This is it. You can circumvent the restriction by using a table expression, such as a derived table. And how do you frame that? This is it. This query will build above with the sole intention of ranking the employees, not the employees, ranking the products. See, this is the main focus of this query. Let's come up with a ranking system of the products by category ID. We rank them all. See, that's just it. That's the goal of this one. And then once the ranking has been done, we generate this table called T1. And now we go above. See, this is the parent query. And then this is where we impose that condition. This condition we're trying to impose it in the inner query. It was not working. Remember option 1. Option 1, use that alias directly in the where clause. It was not working. This is an alias. You cannot use an alias in the where clause. But if you build this inner and you go outside this rank number, which is an alias, it's no longer an alias if you're querying from the outside. You see, this is it right here. It's not an alias. This solution will execute. And this is always a challenge with students. You see, they try to force things in one query. Right? So use this strategy whenever you have those kind of challenges. It will help in a lot of problems, right? And that's the same thing with the Uber example. We're going to rank the Uber rides for each user. So you have to partition by user ID, and then we order by, how do you rank Uber rides? By date. The date will give you how the rides came in. So for each user, that's partitioned by user, we rank the Uber rides, that's order by date, transaction date, or order date, whatever. See, and then this is the sole purpose of that, so that we see the rights of each Uber ranked. See, and that's the focus of this. Now, once they are ranked, you can now go outside, do a select star, and you put this condition where the ranking is equal to 3. This will give you the third transaction of each Uber rider. That's the next question we're going to solve. See that? Because if you want to force all of this, I've shown you those 3 possibilities and they all failed. And now you get frustrated. Option 1, take the alias from that column, put it in the where clause, it fails. And you get the error message. This is it right here. Option 2, copy the entire logic. Instead of using the alias, use the entire logic. This is what we've been doing previously. But unfortunately, this involves a window function, and that's why we get this error. Right? A window function cannot be placed on a where clause. This is us placing a window function in a where clause. Right, so at this point, you can just see here the query you've built successfully. Yes, it's good. Put in the inner query. Go outside to the parent query and apply the logic that was, giving you errors. Apply that to the outer query, and this is it. In this query, rank number is an alias, and this is it. As this is an alias. But if you take it to the outer query, which is this is simply a column in table 1. It is no longer an alias. It is considered now as a what? A full-fledged column. Remember, this right here is extracting data from T1, table T1. In table T1, rank number is a column, not an alias. Rank number is an alias to this query. Once that query has been extracted and stored in this table called T1, that alias called rank number becomes a full-fledged column. Now, this is very important. And so that's the strategy. I think we have the HR one. Let's start working on this. Let me see if I can connect to this. Okay, connect. Let's use this as our first example. Let's build a query which will retrieve the employee ID, employee name, department name, and salary of employees with the N highest salary. Right, this N could be any number. This is a very popular interview question. N could be any number. First, highest salary, second, third, fourth. So you're building one query in which anybody can just plug in a number and it will give you the outcome. See that? So what is your goal? Your goal is to build an inner query which will first of all rank all those employees That's the goal of this inner query. And in this case, you can use the dense rank, you can use a row number. In fact, let me just switch this to a row number. Some questions will be very specific and they'll guide you on what particular window ranking function to use. Let's say I went for a row number function. See, the advantage of a row number function, right? If two or more employees have the same salary, the row number function will give all of them different rank. You see, you cannot have duplication on the row number function. It gives you unique sequential numbers, right? So this is it. Let me show you what the inner query has achieved. So you're splitting your question into simple steps. One very powerful step has been performed in the inner query, which is what? The ranking of employees based on salary. This is a very powerful step we've done in the inner query. So you read a question and you choose a very key step to perform in the inner query. This is it, right? So you have to understand the focus of this. It is ranking the employees based on what? Salary. See, we have not partitioned, so we are considering all the employees into one window. So we have one window right here. Of course, the row number function needs order by, so we are ordering by salary descending. So row number 1 will go to the employee with the highest salary. See, this is the employee with the highest salary to get row number 1. And how do we know this is a row number function? Because it is unique and sequential. Those are the two key terms you need to use. When defining a row number function, then the outcome is unique and sequential. Sequential means you go from 1 to 2, 3, 4, 5, and just like that, you see. And then the numbers are unique. So unique sequential numbers, that's the focus of the row number function. And since we did not partition by anything, this gives you what? A continuous. And that's one thing to know if a partition by was used for the row number function. The fact that you see the numbers are continuous, there is no break in point and then the function resets. This is only possible when a partition by is done. So it gets you a different window, it resets and goes back to 1 and start counting all over again. But you see, it is continuous. You see a continuous behavior of this. It's a clear indication that the partition by was not used in this function. So this is a very powerful thing. And that's the same thing we're going to do for that Uber stuff. You have to rank the rights. Which one came first, second, third? Key step. You see a lot of questions that are in that direction. You begin by, first of all, ranking the stuff. So you dedicate that entirely to an inner query. Once that is achieved, you now go outside, see, and you start performing that end salary. So this is what you get. If I ask you the employee with the 10th highest salary, this is the person right here. It is simply what? Where rank equal to 10. But remember, you cannot just go to this query and you put where rank equal to 10. That will lead you to the first error we had right here. Option 1, first error. We are using the alias directly on the where clause. First error. You see? Second error, we took the logic itself. Since the alias failed, we took the entire logic itself, put it. That's a window function. Second error. And finally, we gave up and say, you know what? Let's just rely on our derived table. And it helps, you see. And this is it right here. Right. It's the question we're solving. So when you say the n highest salary, n could be any number. You see, that's why I put in parentheses n equal to, it is anything you can imagine. Right. Give me the employee with the 110th highest salary. So the key thing is that classification. Rank the employees based on salary. That's a huge step you've done. Right. And once the ranking is done, put that in an inner query. Go outside for extra logic. What's the extra logic? Select the data, the recommended data, and then you bring in this where clause. If the rank is equal to 3, then you're looking at the employee with the 3rd highest salary. Just keep changing that number and see what happens. So if I run this is the employee with the 3rd highest salary. See, it fetches only that and return it. If I change this to 10, I'm getting the employee with the 10th highest salary. The powerful stuff has already been done in a separate query. That's the ranking. All right, this is the power of you splitting things You see, this is returning a table. That's why it's called a derived table. And that table has a name. It's salary ranking. And then you can now go to an outer query, return, and any column you're calling from the outer query, that column must be in the inner query. You see, the parent is giving you what the child has offered or rendered. This is also one very huge error. Anything you want to fetch from the outside, you must include it in the inner one. I think we know this, you see. You have to understand that this outer query is extracting data from the inner query, the inner table. So if a column is not extracted in the inner one, you cannot call it in the outer one. And that's why every column in this must have a name. This is another mistake students do. For example, I build this and no name. Remember the condition, your result should give you a relational one, meaning that every column in the inner query must have a name. If I go back to that first strategy, step 1, write an inner query that returns a relational result set. The inner query is not allowed to have an order by, two components of a relational result set, no order by, and also every column must have a name. Yeah, this is very important. Right. So check this. So check this out. If we put everything together, understand the focus of this is the ranking. That's a key thing in this study. In this business requirement, you have to be able to rank the employees. The goal is what? The earn highest salary, where n can be any number you plug in. But this is key. See? And once you've achieved this, you don't want to mess this query. This query has done a significant part of the question, the ranking of the employees. You see, all the employees have been ranked from the highest salary, row number 1, to the lowest salary, which is an. Now you can now sit back and call any number. You don't want to mess with this. The structure has already been built. You want to go outside now and build that condition to fetch any number. And this is it. This is very important. Right. Any question on this? So far, are we good? Maybe let's get more examples. So in this example, every employee was treated to be in the same company. In the second example, we want to see employees with the highest salary in each department. Like, you can solve this question by showing department, and then you do a max on salary. So it show you each department, then you group by department. But the fact that we are able to introduce other columns into this dynamics, you see, it's making this way more on the ranking side, on the window function side. So in this example, we're gonna modify it. You see the modification. Give me the employee details of the employee with the highest salary in each department. This one we just saw in the entire company. That's why we did not partition. If you want to do this analysis and focus per department, you have to understand that there must be a partition by department. So that's a modification. I can just go back and use the row number function again. All right. So in this one, the employees are now ranked based on their department. So the window is defined by the department. This is very important. And everything stays the same. So if I execute the inner one, this is the inner query, execute. This is what we get. So the ranking is done by department. If I ask you the question, how was the row number function built? Was there a partition by? The answer is yes. Because in the partition bar, you see that the function resets itself after every window. The numbering is not continuous. This is the point I was trying to make in the previous example. I've seen interview questions like this, especially MCQs. Give you an output table like this. No, not this one. Just imagine you never saw this query. This is executed and they give you this result. They look at this. They tell you the first column in this output is built from a window function. They want you to identify which window function was used to build this. Now you go through and you start seeing unique sequential numbers, key characteristics of a row number function. And you can even check these two employees have the same salary, but they will rank differently. Only the row number function will do this. A dense rank and window function will rank them the same. See? So by looking at this output, you can actually deduce the window function that was used. So there are key things to just observe. What window function was used to generate this column? It is definitely a row number function. You see unique sequential numbers. That's it, the framework of a window function. And then the next question, was the partition by clause used in the window function? How do you know this? You just go through. Do you see any reset? The numbering is continuous. There's no reset. See? So it means that all of this constitutes one window. And if all of this constitutes one window, it means no partition by was used. So this is reverse engineering, where you move from the table, the result, to now deducing how the query was built. I've seen this a lot in interviews. See, this is the best way to challenge you on topics and concepts. See, so this output is different. Now let's project this output and have the same conversation. Imagine you never saw this query, but they gave you this output and I ask you the same question. Opening statement question, column 1 was built using a window function. Sometimes they can tell you the group, maybe the window ranking function. Of the window ranking functions we use to build column 1. Key test, just go to ties. That's what differentiates. A key example is a tie right here. See if the function returns different numbers for the ties. That's the deal breaker. See? And since this function has returned different numbers for the ties, it means that the row number function was used. And you see that there are sequential numbers, see, unique sequential numbers. Definitely a row number was used for this column. Now, in the build-up of the row number function, was the partition by used? The fact that you can see that the function resets, it starts 1, 2, it goes back to 1, it goes back 1, 2, 3, it goes back to 1. You see, this behavior is only possible when a partition by is used. It means that a window exists. The window has been subdivided. And upon close examination, you discover that this right here is the clue. The window was partitioned by department name. Because if I zoom into this, these are the two employees in the accounting department, and these are the ranks of the salary. The moment I go to the next row, it's a different window. It goes, the function resets. That's the technical terminology. The function resets itself after each window. That's how you know a partition by has been used. Without partition by, like we said, the numbering is continuous. The behavior of the function is continuous. Like we see right here, no partition by, execute unique sequential numbers continuously, no reset. So we have one giant window. In this case, the question wanted us to do this for each department. You see, there's a partition by department name, and this is what the inner query build generates. See, this is very, very important. So now the focus is what? The highest salary, the employee with the highest salary in each department. If I zoom into the accounting department, these are the two employees. Which one has the highest? So whenever the rank number is equal to 1, you're looking at the employee with the highest salary in that department. And this is what the system will now just go and fetch. Whenever rank number equal to 1, you're looking at the employee with the highest salary in that department. So that's what you're going to put in the where clause. If you force that where clause inside this query, you're wasting your time, because you will need to use either option 1 or option 2 we've seen above. Option 1, take the alias, use it, you get an error. Alias cannot, you see this thing right here, you cannot put it in the inner query, in this inner one. Let me show you that. And that's why we're going outside to apply that logic. You see, this column is invalid. You have to understand that an alias cannot be used in the where clause. The only spot where an alias can be used is in the order by. This is very important. And then the second option, this is option 1 from above. Option 2, we copy the entire logic, this, and we place it right here. In fact, just let me back up a little bit. Maybe explaining this in the same. Let me take this. I'm just going to extract just this, and so that we can revisit those option 1 and option 2. So execute. This is what we have. So what's the strategy? If I ask you this, how will you get the employee with the highest salary in each department? The ranking of the salary has already been done per department. You see, there's a partition by, and we are ranking by salary. You see, the fact that we see descending means the highest salary gets row number 1. So all you need to do is just to add a where clause and make rank number equal to 1. Because if you put rank number equal to 1, this is accounting. Rank number equal to 1, employee with the highest salary in accounting. We go to the next window. This is just 1 employee, so we return that one. We go to the next window, 3 employees in this department, executive department. We are returning which one? This one. So the framework has already been built. You just need to go now and extract the information. So the key column, the key condition to add and finalize this will be a where clause. Now what will be the strategy? From that result you see right here, we're talking about rank number equal to 1. Now the only problem with rank number equal to 1 is that rank number is an alias. Right? The initial column was built without a name. This is the name we provided. It's not coming from the physical table. Rank number is not a physical column in the tables we've combined. See, the where clause cannot accept that. See, because in the execution of the select statement, by the time the system first of all processes a where clause before it processes the select. So since rank number is something we build in the select, it's not part of the physical columns in any of the 2 tables we've joined, the system will not recognize this at the point of processing the where clause. So if I run this, I'll get an error. Invalid column name this. This is that error we had in option 1. Since I did not execute, let me just back out. I'm going to use an example to demonstrate what we saw, so that you can understand this. I don't have the TSQL 2012 database. So this is the explanation for option 1. Using the column alias in the where clause. You cannot use a column alias in the where clause. What error do you get? You get this. That column is invalid. This thing is misbehaving again. Right? So please, you have to understand this. So that was option 1. You cannot do this. You can use this on the order by. See? Because the order by is logically processed after the select. So after the system has processed the select and now recognize our alias, yes, we can now proceed to use the alias in the next step, which is the order by. That's allowed. See? And then next, this is just something you just have to know. The row number functions cannot be used in the order by. They are only supported on the select and the order by. You cannot use them, sorry, on the where clause. This is a row number function we are placing on the where clause. The system will give us an error. And this is the error right here. Right? So the next thing we are left with is, just make use of our derived table knowledge. The query we've built, just put it in a name query with this. This is it. Just give it a name. Just put it around a set of parentheses, give it a name, and then go above to the parent query and continue that same logic we're trying to force in the inner query, and it was not working. That's just the foundation of this. See? Right. So in this strategy right now, employee with the highest salary in each department, you don't have to bother to force that where clause in the inner query. Just take this and give it a name, and then go outside and do a select star from. Now bring the where clause and include that alias you had. This is a physical column in this table. It is no longer an alias, so we can refer to it like this. But you cannot put this in the inner query, right? And that is really powerful, right? So that's the error right there. So how do you solve this? Just stop right there, remove this, or you can just get it out. Bundle this into a subquery. This is all the steps. Remember, the first step was to build the inner query. We'll build it already. This is the inner query. Give it an alias, and the steps of giving an alias is what? Do this and this, then put the AS keyword, and you can just call this T1. I always like to keep it simple, right? And then next, I go above. Remember, in a derived table, you're going above for the parent query. In a common table expression, CTE, you're going below for the parent. See that? Next step, we're going to target this. So I want you to start seeing the difference. The parent query is placed above. I can just stop right here and do a select star from what? From T1. But then what is T1? If I stop right there, I get an error. What is T1? T1 is that named query. This table is derived from this query. See, and it's always good now to indent so that you can see. So that when I bring the where clause, you can clearly see that the where clause is a continuation of the outer query or the parent query. See, this is it. Now this condition is applied now to the parent query, not the inner query. Right, and now this will work. See, this is really, and see, this is it. And if you notice all the ranking points to 1, these are the employees with the highest salary in each department. So just imagine the HR requested a list. I want to know the top earners in each department. This is what you build. So we decided to make the job easy. This is only doing the ranking of the salaries per department. That's the focus of this table we build. This table does not exist in it's not stored in the database. This is very important. Right? This is, see, build that with one focus, powerful ranking of the employees. And we've dedicated that into T1. We now go above and say, select star from T1. We now bring that condition. Right? And this is it. And remember, since we did an inner join between employees and department, we are only seeing employees that were assigned to department. Right? If I do, for example, a right join, I am prioritizing the department table. Are there some departments with no employees? If I show all the departments, you notice that this is going to be a little bit different because now I'm prioritizing all the departments. Right? See what happens. You start seeing some null showing up. Right, let me show you this difference. Inner join will only show you employees who are currently in departments. And that's why the result here is fewer, 107. Are there some departments without employees? Is it possible? Let's investigate. Now you're going to look at the positions of this and this. Department is on the right-hand side. If you do a left join, you are returning all employees, whether or not they are in departments. Right, that's why, because you are focusing on the left table. And this is what you get. Since all employees are in departments, there's no difference between the left and the inner in this regard. You see? Now, but then the goal was to prioritize the department table and return all departments, whether or not they have employees. So you see how you think from a business perspective and you act correctly in the SQL analysis. So this would be a right join so that you're prioritizing the departments table. You're showing all departments, whether or not they have employees. Is it possible to have departments with no employees? Yeah, newly created departments. Yeah, you see the number has gone up to 123. And then how do you identify those departments with no employees? It's clear. Something like this. See, benefits department, construction department, contracting department, control and credit department. These are all departments with no employees. See, on the first name, key columns from the left from the employees table, no employee ID, no first name, no last name. See, right? And of course, if you proceed now to the outer, you will still see those departments being listed, but then see no top earner in the departments. See, you don't see the ID, you don't see their names, nothing. So this is a messed up list. Don't do this to your manager except they request for it. So how do you clean up this list? It is wise to show only departments with employees, and that's the foundation of what an inner join. That's why we go back. Instead of showing this messed up list to the manager, yeah, you can clean up this list. We're only showing departments that have employees. So that should be an inner join. See? So let's go back to an inner join. Only departments with employees. And this is the clean list. See? And then this ranking right here was just for you to understand what you're doing. You don't need to show that part in the final result. I think that's what I did right here. You see, the ranking was kicked out. You just see this to confirm. And then the final thing you're going to show are these ones without the ranking. The ranking is just for you to confirm what they're doing is right. So in the final analysis, this is what you're going to present. Employees with the highest salary in each department. This is it. The ranking column has been kicked out, you see. And now your order by can be placed in this final stuff. Remember, we talked about this. For a relational result set, you cannot place an order by in the inner query. Let's order by, for example, department name. Just see, if you read the conditions we saw, see, if I run this, the system identifies an order by in the inner query and gives us an error. The order by clause is invalid in views, see, views, inline functions, derived table. This is exactly what we're studying right now. Subqueries, and then we're going to see common table expressions. Tomorrow we're going to see these other ones. Right. So this is very important and it's listed in this. Let me take you back to the notes so you can see where this concept stems from. This stems from this. The strategy. What is the strategy? Right here. Step 1, write an inner query that returns a relational result set. Whenever you hear about relational result set, two things comes in mind. One, no order by. But there are exceptions. If you must use an order by, then you have to put a top clause. Second restriction, every column must have a name. So I've been able to demonstrate you the error you get if you put an order by in the inner query. Let me go back to that question. So we're looking at employees with the highest salary in each department, and I had an order by right here. This order by should not feature. This is an inner query. It should not carry an order by. The ordering should go to the outer query. That's the position. If you need an order by, put it in the outer query. See, if the order by is present right there, this would execute. See? But don't put an order by in the inner query. Right? If you need it, you can put in the outer query. Right? If we're all ready now, we can target that popular Uber stuff. I think I've mentioned this example over and over to you all. We're gonna do it together. So first, let me share this link. I just hope my Uber stuff will execute. Please go back and execute the Uber database script. So before we solve this question, we need that database. Right? The transactions table is actually right here. So you see, I've modified this code. I've done a select star from transactions. We order by the user ID and the transaction. This is just an exploration so that you can start. Anyway, I'll begin by, I want to make sure we all have access to that script. Please, can we all execute the Uber database script? I provided this is right here. I don't know if this is the first time I'm providing this. So before you execute, can you just check? I don't know if I provided it sometime in the past, we executed it. So just go and check if you have Uber database script. It should be somewhere around the U area. I don't have it, so I have to execute. So this is a script. Hope this is not going to take forever for my case to execute. Just run. Okay, that was fast. Yeah, so database has been executed, the script. Once you have it executed, just shut it down. Why my system is trying to configure itself? I'll just take you to this. No, this one right here. So the title of this exercise is Uber's third transaction. And this is actually an Uber SQL interview question, right? So this is what we have. So assume you're given the table below on Uber transaction. This is a table right here. You see, select start from transactions. So transactions made by Uber users. Write a query to obtain the third transaction of every user. So the fact that we have every user, what does that mean? It means that in the ranking of the transactions, you have to do it for each user. So there must be a partition by. You saw how we did this partitioning by department ID when ranking the employee with the highest salary in each department. We had to partition by department. See, so, and then you see, since the ranking was based on salary, we do order by salary descending. The ranking for Uber transaction is done based on what date? It's a transaction date. See that? So after you've ranked the users based on, after you've sort of partition based on the user ID, you have to also rank or sort, sorry, based on transaction date. So this could be a nice exploration to begin with, where you just simply visit that table. Let me just put this on a new query window. I'm going to switch this to, oops, this thing is still. Just a moment, I'm going to shut this down. So this is what I'm targeting. I will see what I've done right here. I do a select from the table. I order by user. This is just exploration. And then within each user, we sort by the transaction date. So this is what we have. You can clearly see that this particular Uber rider made a total of what? 3 transactions. This is how the partitioning will look like when you partition by user ID. This will be the user ID 111 window. And you're going to see, we're going to sort based on the transaction date. So this user, this is already sorted correctly. This is January, 8th of January, first ride. 10th of January, they had their second ride. Then they waited until the following month, 5th of February, to get a third ride. See that? And so for this analysis, we are interested in this ride only. This is the third ride for this user. Remember, the title of this analysis is what? User's third transaction. So this arrangement is very important, and we are doing this in a window function environment. We first of all have to rank the rides. So for this particular user, this would be ride 1, ride 2, ride 3. See, we go to the next user. We also rank their rights based on date. This user had 3 rights as well. The first right came on the 18th of January. Next, sometime in April 1st, April 3rd. You see, the rights have been ranked. This will be rank 1, rank 2, rank 3. And what are we interested for this user is a third right, this one. We go to the next user. This person had just 2 rights, so they do not qualify for a third right. So we're going to drop this person, see? Because at the end of the day, we're going to take where rank number or whatever column you give to that ranking is equal to 3. That's how you get Uber's third user's third transaction right. This is very important. All right, if you go to the next one, you see this person had just 1 right, so they do not qualify. This person had 3 rights, Right, the first write came on the 11th of this month, on the 11th of this other month. You see, it's on the 12th, just one day after. So this is a third write for this individual. So for this window, we're going to have rank 1, rank 2, rank 3. Right, so you're going to do this in an inner query. If you look at strategy right here, and this is it nicely spelled out. So this is where the query above goes in. This is the ranking of the rights. See, row number over partition by user ID, order by transaction date. We call this the row num column. See, so now this will go into this, and where the row num 3, that's where we're going to insert that. Let's build this together. I think, let me see if I can launch my management studio again. So you see what they're doing right here. The first solution, first strategy is to rank the rights for each user. So show me the user's ID, the amount spent, the transaction date, and this is the column which we'll be targeting the ranking. And if you notice, there is a partition by user ID. We don't want to mix up the rights. We want to rank them for each user. This is very important. And then if you look at it, there's an order by transaction date. What is the best way to rank the rights of riders? Let's follow the date, so that we can know which one came first, which one came second, and stuff like that. So that's why we are having an order by in that window environment. You see, there's an order by. You have to understand row number functions, all of them, those window ranking functions, they all need an order by. So now you have a sense of what we did. This is similar thing we did right here with the order by first user ID and then transaction date. Same kind of stuff. So this column will now be added, which the alias it will be what row num. So there will be a row num column right here, which will rank this one as 1, 2, 3 for this particular user. See, give me the user ID, which is this. Give me the spend amount, which is this, and then give me the transaction date, which is this. And then to that, add this logic, and then put that in a new column called row num. Row num is a new column, right? This will simply give us 1 for the first transaction, 2 for the second transaction, 3 for the third transaction. It stops right there. Since it's a different user, the function resets and goes back to 1 for this user, 2 for this, 3. It's a different user, it resets. That concept of resetting is very important to understand. So enough talking, let's get to work on this. Let me see if this is going to run. I'll probably have to end up uninstalling Management Studio and installing it again. Let's go to Uber. Use Uber. So we're dealing with the transaction table. Select star from this is a very simple table. It should run very quick. See processing. Okay, so this is the table we have. So what we're gonna do is, let me set the framework. So we're gonna build the inner query first, which is gonna do just one thing: ranking of the rights per user. Right. That's the main focus of the inner query. We want to give that task to the inner query. Right. So in this task, we're going to request the user ID. Give me the amount spent on the right. Give me the transaction date. Transaction date. And then finally, we now have to do this ranking. Right. So I will invoke the row number function. Right. There are 3 ranking functions you can use: row number, rank, and dense rank. Right. I want to get unique sequential numbers for each of the ranking. So I'm I'm going for the row number function. Right. Now this is mandatory. Every window function needs an over clause. If I stop right here, I've made a mistake because this is ranking. You're ranking based on what? So you're ranking based on the transaction date. This is very important. I have to put an order by transaction date. This is very important. Now, we don't want to study all the information across every rider. We want to do it for each rider. So that's why there must be a partition by user ID. The user ID is what identifies each rider. So we're going to do a partition by user ID so that we, for limit the ranking of the transactions, the order of which the transaction came in for a particular user. This is very important. So hopefully everything is understood. Now this, if I execute this, I get a new column which we did not have in this table. And that's why this, I remember the inner query must have a relational result set. Look at the condition we talked about. So there must be a name. You cannot just give any name to this column. Right. If we just go with what we've been using, this is a rank number, for example. So we've ranked the writes carried out by each user in the order in which they occurred or came in. Right. And then you can actually stop right here and test what you've done. Let's zoom into, since we have a partition bar, you have to zoom in and focus on one user. Remember, the partition is by user. So let's make sense out of this process. Let's understand this window. These are the columns that appeared in the table, the first 3. Let's focus on the last one, which is key to this analysis. Now let's go by the date. We are ranking by date. See, not by amount spent. No, this could be a different question you could be asked. The most expensive Uber ride made by each rider. In that case, the ordering will be done on the amount spent. You see, so this is different. Here we are ranking the rides in the order in which they occurred, because the basis of the question says the user's 3rd transaction. How do we know first transaction, second, third? Is by the transaction date. This is very important. So you have to understand, is for this particular user, is this correct? Is this the first date, the first transaction? Yes, this is the 8th of January. Second came in 2 days after, and then this one came in the following month. You see, this is correct. This ranking is correct. So in this question, this is the transaction we are interested in for this particular rider. If you go to the next rider, this next window is this one. Is the ranking correct based on transaction date? See, is this correct? This is the 18th of January. This is the 1st of April, 3rd of April. This is correct. This is correctly ranked in the order in which the transactions came in. For this user, we're interested in the 3rd one, this one. You see? Now we continue. This person had just 2 rights, so they do not qualify for a 3rd right. So when you put rank number equal to 3, there will be no right for this result for this particular user. If you go to this, same thing, this person has just 1 right. See, now this person had 3 rights, so they qualify for a 3rd transaction, which is this one. This is what we want. So we're simply going to visit each of the rights, each of the windows each user, and we're going to extract the third transaction. So it's going to be this for this one. So I'm only looking at where rank number equal to 3. This, and this. Right. You cannot introduce that in the where clause of this query. Right. So this, we're going to use that logic and frame it into an outer query, into an inner query with a name. So first step, build an inner query. So this is our inner query, which we build above. This is going to constitute our inner query or the subquery. Right. And then this is made out giving it a name as this is the name. This query runs, generates this result, and we are storing this result in a table called, I always like to keep it simple, T1. You can give it whatever interesting name you want to give it. Now go outside and build the outer query. Outer query is just going to be select star from, see, that's the outer query, right? And if you stop right here and run it, your inner and outer query are showing the same thing because there's no condition to restrict, so you get back everything. See, but then what is the final thing to do? User's third transaction. Each user's third transaction. Each user's third transaction. That is the goal of this question, right? And how do we get this? Since we put the rank the transactions in the order in which they occur, we just need now to put where rank number equal to 3. That's it. See, and we are doing this from an outer or the parent query. So that, see, and if you start typing rank number, see the beauty, it shows up. This is rank number. But if you go to the inner query right here and you start typing rank number, you will never be able to pull up an alias at the level of the where clause. See, rank number is not showing, right? Because at the moment when the system is running the where clause, we have not yet executed the select, which is where the rank number alias column is generated. Right, this is clear. For right here, try typing rank number. It's not going to show up. The IntelliSense will not even pick it up. But then remove it from here. If you're typing rank number, it has already been packaged and stored into a column called T1. So rank number is a physical column. It's no longer an alias in this T1 table. And if you're doing select star from T1, you can call it. See, the system has it on the list for you. This is a rank number. And you can now put where rank number equal to 3. This is how you extract the third transaction of each Uber rider. Everything points to 3. Now you don't need this information. You don't need to project it to the end, to your manager. So you just have to go back and say, okay, I need the user ID. Right, I need this column. I need this amount spent and the transaction date. Just copy this. I don't need to show them that logic of the 3 is not important, and this is what you deliver for that question. Right there. Right. I want to stop right here and give you time to explore that question. And please just read through this. This guy did an excellent job of showing you the steps. First, we obtain the order of transaction numbers for each user. We can do this by using the row number window function where we partition all the transaction by user ID. And then we sort by transaction date. This is it. So row number function over partition by user ID, order by transaction date, and then they call this column row number. You see, in our case, we're calling it the rank number. Right. That's the first thing. This is very, very important because it generates an outcome such as this. It's just a snippet of that. You've been able to now sort the transaction of each user in the order in which they occurred, and you've given it numbers, and you've actually defined a column that captures that information. Right. Because the goal is to hit towards a where clause. In a where clause, you must identify the column you want to impose a condition on. So we've already built such a column. This is it right here. And if you now impose row number equal to 3, you're getting the third transaction, right? So this, I'll encourage everyone to read this fully. And they did this using the subquery, that's a derived table. And this same question has been solved using a CTE. We're going to study CTE after the break. Remember, the focus of today is subquery, that's derived table versus CTE. Questions you can solve with a CTE, right? You can also target that same question and solve it with the derived table. So they've given you the two options. Solution one, using what we call a derived table, is a subquery in the from clause. This is a subquery. You can see the parentheses enclosing the subquery. You can see the name of the subquery, and the subquery is placed on the from clause, which makes it a derived table, right? And then when we've studied CTE, we're going to come back to this question and solve it using a CTE. And now you begin to put together things and understand why this Facebook post, not Facebook, sorry, LinkedIn. Are you team CTE or team subquery? So if you're given this question, will you solve it with a subquery or will you solve it with a CTE? I think we should take a break. Let me see what we have. Yeah, anyways, we just go ahead and take a break. We're going to continue after the break. So I have derived table and CTE. So let's see what we've achieved so far. So we've solved the Uber example, this right here. So we've solved this. And there's also another one on transaction. Okay, let's do this after the break. There we're going to target the common table expression. So we're going to resume and do this after the break. So after the break, we're going to work with this TransUnion database project. Okay, let's go for a 20 minutes break. I would like to address your questions after the break. Okay, see you after the break. Okay, guys, are we back?
Yeah, yes, I'm back.
Okay, so I want us to take a look at this example. We want to count the number of customers in each credit rating category. I think we solved this question in one of the labs. This is a transition database. And this is a separate column we had to build to get the rating of each customer. This is a case statement. Right, so we had to go through a series of conditions. If your credit score is between, for example, this and this, you have an excellent credit score. So we have to build these different categories, these different ratings. And if you look at this question, they want us to count the number of customers in each credit rating. So how many customers had an excellent credit score, very good, stuff like that. So if you want to, fuse all of this into one query, it could be, it could be difficult, and then readability could also be an issue. All right, so what we can do is let's address the idea of classifying the customers into the different ratings based on credit score in one query. That's the inner query, this one right here. And if you look at it, this is the only job of the inner query. Just go in there and get us the ratings. See, so take each customer based on their credit score, identify the correct rating to which they belong, and that's how we end up getting this. So if we're given this table, imagine you had this table and they tell you now to count the number of customers in each credit rating. Working on this, it will be easy. You just simply do select rating, and then you do the count function on customer ID, and then you group by rating. That's it. So always try to visualize, the big picture, and then know how to extract a certain table and then apply a logic on what you've extracted. And that's exactly what we're doing right here. So we've extracted this information, and we'll store in a table called customer ratings, and all points back to this concept of today, right? So you fetch the information you need for a second phase of the analysis. Right, in the second phase of the analysis, we're just going to show each customer rating, and then we're going to be counting the number of customers, and then we're going to group by customer rating or the ratings column. See, instead of struggling to fuse all of these into one query and solve it, right? This is the first phase of the information. Capture what we need right here. That's what we need. And then now go ahead and do the counting. So show me each rating and see what the outer query comes in to do. This is the outer query. Show me each rating and then count the number of customers. This is what number of customers. And there must be a group by. See, and that group by goes to the outer query. See, I've tried to indent the inner query. This is it. And nicely, this is how you end up solving that question. See, you clearly see the different ratings from very poor all the way to excellent, and the number of customers within each. If you struggle to use one query to solve all of this, it's going to be cumbersome. It's going to be, too much going on. Right? But when you solve it like this, somebody can run the inner part first, understand what was captured, what does this customer ratings table holds. It holds the output of this right here. That's a derived table. This is it. Given this information, can you now count the number of customers in each rating? Easy. See, we simply state the rating, and then we count the number of customers, and then we must do a group by. That's it. You see, and if I can actually explain you what I did, and you can follow through and understand it. Nicely done. See, so that the power of this, you have to know this. It's going to help you a lot in questions, in problem solving. Right. Now, this is an interesting question right here. The top 3 most expensive vendor orders for each vendor. Right. I think we should be able to build this together. Right. And this is similar to what we did in the Uber transaction stuff. You have to come up with some ranking arrangement where you can use a row number, rank, or dense rank and you rank all the orders for each vendor. There must be a partition by vendor. You see where we are heading to with this, right? And then from there, after the ranking has been done and the partitioning, that will be the job of the inner query, right? Then our outer query will now simply come to isolate the most expensive one. So after ranking maybe one, each rank that has equal one, that's the most expensive. And then where the ranking equal one, you're getting the most expensive order for each vendor. It's all about strategy. So write a query that displays 3 most expensive orders per vendor ID. It must be a partition by vendor from this table, right? There should only be 3 orders per vendor ID. If two orders have the same amount you're tracking in terms of most expensive, then if you use the rank function or the dense rank, they're going to have ties and they're going to be, but if they tell you there should only be 3 records per vendor ID, which of these will you use? See, to ensure that only 3 is returned, you must go for this one. See, sometimes this will now give you a clue as to which one to choose. I'm going to explore all 3 so that we can settle on and understand why we need the row number. Unique sequential. If 2 orders are tied on the total due, it depends on the column you're going to be using. Okay, the right here. And even if some of the total amounts due are identical, right? So there should only be 3 records per vendor ID, even if some of the total amounts due are identical. Right? And then the go ahead tell you the most expensive is defined by the amount in the total due field. So you're going to sort by order by total due descending. This is what you put in the window function. See? And everything I'm explaining, please just switch this to 2022, execute. Right. And this is basically what I've been explaining. Right. So we are using this table. Right. So this is the part where we're trying to do the ranking. We are doing this ranking per vendor ID. It was stated in the question. Right. Three most expensive orders for each vendor. Right. And there should only be 3 records per vendor ID. See that? So we have to partition by vendor ID. Right. And most expensive was defined. Most expensive was defined as the order with the highest amount of total due. So you have to use the total due column to identify or classify the most expensive order. See, so within the window we are partitioning by first vendor ID. Sorting will be driven by total due descending. So now when you bring in the row number function to this structure you've defined, you have to understand that the row number function targets what you've defined and then performs its job. So this is a framework we've built. We are partitioning by vendor ID. Visualize that process. Now within each vendor ID, we are sorting within each vendor ID window, we are sorting by total due descending. So what is row number 1? For a particular vendor, it will be the most expensive order. That's the highest total due. So if I execute this, I think it puts everything into perspective. You have to start by zooming into a particular vendor based on what the ID. Right, this is going to be a large window. So I'm already targeting this vendor. If you see, same vendor all the way. This is huge. Oops, okay, right, all the way to this. See, this vendor had a total of 51 orders. And you see, these orders have been ranked based on what? Total due, from the most expensive to the least expensive. You see that the most expensive order from this vendor is this one. This is the highest total due. and we've ranked at 1. The question wants us to extract only the 3 highest, 3 most expensive orders for each of the vendor. So for this vendor, these are the 3 we are interested in. You have to understand that in this, if we use dense rank, you see these are ties. If you use a dense rank or a rank function, this is going to be 1, this will be 2, this will be 2, and then this can be skipped to for a continuous you see. So it's not going to help us achieve this objective. This objective was very specific. This is where you get to know what window function to use. This right here. There should only be 3 records per vendor ID, even if some of the total amounts due are identical. Right. So don't use any function that will render identical ranks for ties. It's a tie right here. This should be treated separate, and only the row number function can achieve that. So for this particular question, I think this is the first question I'm actually showing where the question itself dictates what specific rank function or window function to use. Right. So you have the 3 options right here, and we're going for this because this is the only function that will guarantee that even if 2 or more total due amounts are identical, the function will return different rankings so that we guarantee that 3 rows will be returned for each vendor. This particular vendor 1492, they have 51 rows. How do we guarantee only 3 rows to be returned? Is if the rank function returns unique sequential numbers. So when you say in 1, 2, and 3, if you look at the final result, we're going to target how do you extract the 3? This is what you're going to do. Where they rank in 1 to 3. Remember, we're not extracting one row like in the Uber example where rank number equal to 1 or row number equal to 1. In this case, we are extracting the top 3 most expensive orders for each vendor, right? So how do we extract these 3 information at the end of the day for this particular vendor, right? And how do we extract the next 3 sets of expensive orders for this particular vendor? Now this vendor goes, right? Focus on the vendor ID also, going to the purchase ID, that's wrong. So for this particular one, see 1494, just follow through and see where 1494 takes us to. All the way, it's another 51 orders, 1494. And you go to the next one, 1496, another set of 51 orders. See? Go to the next 1498, another set of 50 orders for 1498. You see? For 1500, how many orders came in for 1500? 50 orders. You see? So how do you guarantee that you only extract the top 3? And since you've sorted based on total due, you're looking at the top 3 most expensive product for each vendor. Each vendor's list, you see. All right, so this step is very important, that ranking, getting this outcome. Right? And once you achieve this, you want to preserve this. This is something strategic you've achieved. You want to preserve this in a table. In this case, you want to preserve this in a table called T. This is it. We are preserving in a table called T. And then we go in the outer query and include a strategic condition which will hit our target. So for you to extract the top 3 rows or top 3 most expensive orders for each vendor, you have to make sure that your condition includes this. If you're in 1, 2, or 3, if your rank number is in 1, 2, or 3, then that is the top 3 most expensive orders for that particular vendor since we have a partition by vendor ID. So if I execute this, you notice I'm just putting this so that it serves as a guide. Each vendor, you're going to see 3 expensive orders. The moment you transition to another vendor, that's a change in vendor ID. You see the next, see 3 most expensive orders. The moment you transition to another vendor, you see 3 most expensive orders. You see, just like that. And that accounts for the 248. If we ask to get just the most expensive order for each vendor, then you can do rank number equal to 1, or you can do rank number in 1. Yeah, in can also be used if you have just a single value, or better still, you can just put rank number equal to 1. See, for each 86 vendors, we have 1 order being returned, which is what the most expensive order for that vendor. See that? All right, this is very important. All right, so let me just go back a little bit. I want to pause right here. Questions. This thing right here is very powerful, guys. So I want to pause right here and give you time to go over the first part of this question. And there were a couple of hints I didn't even talk about. You will first need to define a field that assigns a unique rank to every purchase order. Which of the ranking functions will return a unique ranking number? So in that one has to, ignore the ties, and the only ranking window function which ignores ties is the row number function. And if you look at the hint right here, it again points to the use of the row number function. See, you will probably want to use window function with partition by and order by. Yes, right. Why did we partition by? Because we are accessing this per vendor. That's why we partition by vendor ID. Why did we use an order by? Total due. The most expensive product was defined as the one with the highest total due. So we are using the total due to sort from the highest to the lowest, so that this row number can now attach and return those rows in that order. Right. Now, what was the next hint? The last step will be to apply the appropriate criteria to the field you created with your window function. Exactly, this is it. The appropriate criteria is this one: the extraction of the 3 top orders, 3 most expensive orders for each vendor. See? All right, so I'm going to pause right here. I want you guys to take a moment and go over this. And if there are any questions, we can address it before I think we've talked about the Uber one. Yeah, it's just a repetition before we get to common table expressions. All right, I want to give you a moment to just let that sink in. All right, any question for derived table? So this is the end of the segment on the left hand side. Next, we're going to focus on the one on the right hand side. Basically, we're going to go back to all the questions we've solved and then just repeat them with the CTE. All right, any question? First of all, let me just stop right here and give you time to go over the syntax of the derived table, right? Because we're going to transition now to a CTE. The syntax is going to change. So I want you to have some time to explore this first before we get to this side.
Mr. Blaze?
Yes, question, Alex? Yeah.
Yeah, let's see, because I was just thinking, right? This is just me thinking out loud. But I
Right.
was thinking, is there any possibility in which we can amend the top, use top to kind of like derive the top ticket of each vendor in this scenario?
Yeah, that's a very interesting question. And the limitation, that also highlights the limitation of a top clause. All right. If we were not doing any partition, then that's fine. The challenge is when you're doing it per vendor. Let me go back to that query and show you the limitation. If I go back to that query, where's the query? Let's just get this. right here. I Control C. I'm happy you brought up that top clause strategy, and this will really show you the limitation of the top clause. First, it cannot partition, right? And then, so if I just go right here, this is the output we have. You see this output, it is made up of 4,000 something row. And if I just go in this output and I just put top 3, see, if I run this, most likely it's just going to fetch. If I run this, it's going to fetch 3, but I don't know the order, how the 3 were extracted. You have to understand that the order of the top clause is dictated by the order by clause. So if I run this query, there's no guarantee that we're going to have this 3. Let me just run it so that you see that I cannot explain how the 3 were extracted. So from the way I see it, it maintained the ranking that was presented. You see, but then you see, it gave us the top 3. Let me dismiss this. It gave us a top 3 from just one particular vendor. See, it took this result right here and gave us this as the top 3. Yeah. This question will work if we're told to get the 3 most expensive orders without partitioning by vendor. If I dismiss the partition by vendor, yes, you can use it. You can use this approach. If I dismiss this one, see, and I just run this, if you look at the ranking will now be continuous. See, 1 all the way to the very last row. See that? And now if I put a top, it will give me the most expensive order, irrespective of the vendor. That question you can solve, you can plug in the top and you're gonna hit your target. If I do top 3 right here, you see. So the problem is the partition. The order by cannot deal with partition. Sorry, the top clause cannot deal with partition. And why do we partition? Because we want to look at top 3 for each vendor. So we are separating the orders by vendor. That idea of separating orders by vendor is difficult to comprehend with the top clause. If there's no partitioning, yes, a top clause will deliver right here. See that? But now, and this same result will be generated if I go to this query and dismiss the partition by right here, dismiss. And then to solve this question, I just need to put, yes, if you look at this, is now showing the overall, irrespective of vendor. And if I give you now 1, 2, 3, this will be the top 3 most expensive orders, irrespective of vendor. As the same thing the top clause is giving. Where is the output for the top clause? This one, you see, this same 3 is the same solution we are getting right here. Is it the same? Let's check the purchase ID 1412, 14, 4007, 4008. Yeah, same thing. Right. But then now, if they modify this question, that's the problem. If they modify this question to tell you, let's partition by vendor. Partition by vendor.
But then again,
yeah.
So this is me thinking again. So what if, can you then use the top now in combination with a group by to go by vendor? Or
yeah, that you can. The top it will not still be able to identify the groupings. And if you bring in the group by, then you're gonna lose the structure we've built so far. Right. You see the power of us seeing all the individual rows. See 4,000 of them. Right. And then we are now ranking each overall, or you can rank each by vendor ID. right? So there's some serious limitation to the top, right? Because the top comes in towards the end. You've built something and then it just goes and extract, right? So it doesn't understand the partitions or the groupings you've done in between. I want you to understand the top comes is one of the last thing that is processed. Let me go back to this stuff we did, the one with the top. Let me show you. So you have to visualize how the top operates. Let me go back to this. So this is the result we've generated. Before bringing in the top, let me deactivate it. This is the result you've generated. There is no partition, no group by. So the top is targeting this output, irrespective of the partitioning or the grouping you've done. It is looking at this as one output, and I'm going to this to extract if I say top 4, or I'm going to this to extract if I say top 3. Just that part is going to carry it off. Right? It will not recognize the grouping you've done or the partition you've done in that process. Right? So once you plug in top right here, it is towards the end of your analysis. You've done this, yes, but I only want to see the top 3. So it doesn't recognize the partitions or the groupings you've done. Top 3 right there. So even if I bring in now the partition by, let me add the partition by right here. Put the partition by right here. What are we partition by? Let's partition by vendor ID. Again, the row number function, since it's a window function, is going to adjust, but the problem is that the top will not adjust. The row number function has adjusted. You see, it is now classifying this per vendor. You see that if you scroll down, you're going to see transitions. This is the end of this particular vendor. The next one is a different vendor ID. It starts all over 1 and continues. See, so but then this is the output we get from this output. If I put top 3, it will go right here and extract this 3. This is just for one vendor. But then that power to put top 3 per vendor, that's that's the concept that the top clause does not, it's not built to achieve. Top 3, you see, it will just come right here and give you 3 for the same vendor, not per vendor. That's a serious limitation of the top clause. See, all of this is coming from one vendor. This is a top 3 for a particular vendor, right? And that simply happens because that vendor happens to be at the very top of that final result, 1492. In this result, 1492 happens to be the vendor we started with. See that? And now if you do top, this is a list of 4,000 something rows. The top 3 is this one. That's how the system rates it. When you put top 3 or even top 10, it will go all the way down. Top 10 is going to extract. So based on what you've provided, this is it. This result give me the top 10. That's how the system rates it. Targets as result and pluck out top 10. So we are basically picking up these ones right here. And this happens to be the same vendor. Even if we ask to do top 10 for each vendor, the top will not pick that information. See, right? So that's a very important question. And from that question, now you begin to see why you can re-strategize this and go more towards a window function. And then we go a longer route. This would have been an easy route if the top could recognize the inherent division or partition or group by in our query. But the fact that it doesn't recognize it, we are now forced to, go a different way, like what we did right here. See, build that in this, and then capture the logic from an outer query using this. Right? Because this has already been built. See, then this is 1, 2, 3. It stops right there. It returns this for this particular vendor. All of these ones will be dismissed until it sees another set of 1, 2, 3. It stops and return it. In this case, you have to do a partition by. See, I was scrolling down to see. So I need to do a partition by vendor. So it's an order by, it's a partition by vendor. Yes, so now it's good. If I run this, I always run the inner one and check before the outer query. Right, so 1, 2, 3, since our target is to extract just the first 3 for each vendor, see, run this. This is 1, 2, 3, stop right there. For that vendor, this is what will be returned. 4, 5, and any other thing that vendor will be dismissed. It skips and goes to the next set of 1, 2, 3. This is 1, 2, 3 for the next vendor, this vendor, and every other one right here will be dismissed. See, it skips and goes to this 1, 2, 3. This is what we wish the top clause could do, but unfortunately, it doesn't look like this. It doesn't go through like what I'm demonstrating. That's an excellent question. I'm happy that question came up. Yeah, the top clause will not behave but the way we want it to behave. Right? It treats everything as a bulk. Right? This is a final thing you've submitted. It treats this as one unit. Top 3, it's just going to extract this. Top 4 is going to give you this. Right? And so on. Top 10, you get this. It's not going to loop through and see that there's a partitioning or a grouping by vendor. Right? It's not going to, that's too advanced for the top clause. Right? Alex, are we good? That's a very important
Yeah,
question. Yeah.
and that was a good explanation.
Yeah, it would have been very interesting to just plug in top 3 and then the thing understands the inherent partition by and then returns it to us. That would have been very easy. See, yeah. Oh, then I'm missing. Okay, right here. Yeah, I think the over one is just a repetition. This common table expression, right? So let me go back to the syntax. I'm happy we have this side by side. So yes, we've been able to achieve this, right? And then work out the strategy on this. Let me just see if I can make up something. Let's go back to Global Superstore. I want to track some information. Let's use Global Superstore. I think we had done this question. Select star from VBO. I want to do an analysis for each year in Global Superstore. Others, I think, comes on S and C. Yeah, I want to do an analysis for each year. So for each year, let's get the total profit. We're just going to be targeting this columns towards the end. So let's return the following metrics for each year. Return the following metrics for each year. So this is a per year analysis. First, let's do total sales, total profit, and then we can pull in the next one. So total sales, total. You see that this is going to be, it's not going to be through a window function. We are aggregating so that, right? So it's just a regular window function, not in an aggregated in a windowed environment. Total sales, total profit, total quantity sold, total quantity, I think let's keep it profit. Yeah, let's keep it like this. Right. So this is what I intend to get for the year. Let's extract that from the order date. Right, that will be an interesting stuff because for dates we have an order date and a ship date column. Which one will you use? There's a ship date right here. There's an order date. All right, so let's extract the year from the order date. All right, so we're gonna use the year function, right, and pass the order date to it. Order date, right, and we can just alias this as the order year. I'm gonna put this in this. Right. So for each of these, let's run this and see. Now this is we're gonna need a group by, of course, so you can just run this and see the distinct of that. How many years are in this analysis? It's 2013, 14, 11. You see, so this is what the group by will do, because in this analysis you're gonna notice that year is gonna be a non-aggregated column. So we will. So for the total sales, that will be a summation of the sales column. Right. See, now we're bringing in summation aggregated column sales, and this will yield this, right? And pretty much we're going to do the same for every other of those metrics we are tracking. For this total profit, that will be the summation of the profit column. So sum of this, sum. Profit, and this will give us the total profit. And the last but not the least, for the total quantity, or that this will be a summation of the quantity. How was that captured? Quantity column here, this one, as this total quantity. So of course, if I execute this, I get this error. See that? What I explained, we need to put this in a group by. Notice the alias cannot be placed in a group by. Alias go only to the order by. This is very important. Right. If I dump this right here, this alias, if we go by the logical processing order, by the time the system is processing the group by, the select clause has not yet been processed. The select clause is processed towards the bottom, right? So the system does not, this is something you build in this query. See, it doesn't recognize this is what you built. The things you build in a query, right, they'll only show up at the phase where that particular keyword is being executed. So if you're executing a group by, what you've built yourself, this is order here, is something you build. It's not recognized. Right? Why? Because it's built in the select. The select is logically processed after the group by. So by the time the system is processing this right here, this does not exist, this order here. That's why it says invalid column. So you have to put the calculation so that it will run that calculation when it gets to that. So when it's processing the group by, it will run this logic. Right. So when I run this right now, the years are given in any order. I can control the behavior of this by adding an order by. You see, now, yes, in an order by, what happens? The order by can accommodate or recognize this, because after the select is logically processed, the next thing to be processed is the order by. By the time the system is processing the order by, this concept that was built by you in the query is now available. This is built in the select. The select is logically processed before the order by. So by the time the system is running order by, this quantity has been built and recognized. See, this is very important. You cannot group by other year, an alias. You see, it flags it an error right here, but why does it not flag it an error? You have to know how to explain that in an interview. Right. This is it. Now, your manager wants you to rank these years based on the way, based on. I just want to come up with something. There's something called we can do a profit margin, or we can do. I just want to come up with something like an excuse to go to an outer query. Having achieved this, you can use this as an inner query and perform some other logic outside of this environment. This is the inner. This is going to constitute our inner query. Right. Of course, you cannot put an order by. Anyway, we have this. Right. Let me go to Google and find out something. Profit margin. Some popular calculation called profit margin in business. Profit margin formula or calculator. Profit margin ratio. It's actually a ratio. So the cost of goods, that is this. I just want to get the formula. It's just this. I know they've put the calculation somewhere in there, but profit margin or profit ratio. Okay, this is what we've achieved. Let's say we're taking the sales divided by profit. Yeah, I think that's the concept of profit margin or profit ratio. and you express a percentage, right? So we have this, right? If you want to really make your work organized, you've captured this, right? I'll take this inner query right here and put it into this environment, right? That will constitute our inner query so that I will go above or outside and continue the logic, right? Remember, if you are attempting to use this in an in a derived table environment, there should be no order by. You're going to have an error. So I'm going to dismiss the order by, and I'm going to transform this as simply providing the name of this. These are named queries, so the query must have a name. So you can just put T1 and then you go above, right, and you do a select star from T1. And what is T1? T1 is defined by this query, right? So we've done some interesting analytics in the inner one, right, to get to this, and then we can now understand that, hey, you cannot use this right here. This is another mistake students do. The column order date cannot be called in the parent because the child has applied a logic on that order date to return a column called order year. If whenever you're in doubt, run the inner query so that you know the columns you can call in the parent or the outer. You can call order year, total sales, total profit, total quantity. Any other thing cannot be called. So you cannot go fetch this and say, I want to call quantity. Quantity is a column, is not exposed to the parent. Quantity is a column available in this table, and this table runs the inner query. So yes, you can access that quantity column as long as you're in the inner query. But outside of the inner query, these are the only columns you can access. And now you begin to understand why every column must have a name when you're dealing with these derived tables. That's what we call a relational resource set. If I run this, let me go back to asterisk, the system will complain that our inner query is not fully defined, it's not relational because all the columns are not written. You see, the error is right here. No column was specified for column 2 of T1. This is column 1 of T1. It has this. So you just go inside and run it. See, every column must be provided. Every column must have a name in the table. Remember, we're trying to build a table called T1. Every column must have a name. This is the error right here. No name was specified for column 2 of table 1. This is the output of table 1. This is column 1. This is column 2. No name. So this tells you this is not a relational resource set. Right? In a relational resource set, 2 components, every column must have a name. So I have to go back and specify the name to that column. First, every column must have a name. In the second, no order by. Right? Of course, we don't have an order by right here. So if I go right here and I want to show the year, you have to understand that this is a column. Right? You cannot pick up any other column that is not listed right here. So if I want to show the year, and next I want to show this quantity, I want to show the total sales. Yeah, total sales. I want to show total profit, and I want to report the profit margin as well. Let's say we have a calculation where we take this amount, divide by this amount, this divide by this. See, so my inner query was dedicated to capturing that information, and I go outward and continue some logic. Right? I could as well do this in the inner one. Right? Sometimes it's allowed. The ones that it's difficult, yeah, you can push it to the outer one, and this is it. Right? This calculation you could still do it in the inner one. Just take the summation of this divided by that. But again, this is just to highlight the way you can transform your thought process and make your coding much easy. Right? And this is it. This is just a column divided by another column. Right? And again, it still works. If you run this, this is what you get. See that division of this and this divided by this, we're getting this. This is the calculation I was looking online. That I think that's a profit ratio margin or something. Right. So don't restrict yourself to just the inner part. Right. There was one example I solved during the lab session where we're looking at the number of employees whose the annual sales was above the target, the quota target. Let me just take you back to that question, and we did solve that using a derived table, but this was just in preparation for the class of today. Let me take you back to week 7 lab session. So this is week 7 lab session. We're looking at the question on subquery, this one. There was a question right here, the very first part. How many salespeople are meeting their year-to-date quota? And we solve that in two options. Option 1, just the way you think about it. We just simply put this condition right here. Let me just dismiss this for now and put an asterisk. This condition is showing you a table, an outcome of those whose year-to-date sales was greater than the quota, the sales quota as defined by the company. In this question, you need to, this is, I just want to switch database. So if you look at the subquery option right here, this thing is not allowing me to, this is the inner query or the subquery. There's a derived table option. We simply achieve this by setting this condition. We build a table of only those whose sales are above the sales quota as defined by the company. And then we go above and do a count on what we've captured below. Right. So this is an example where we use that concept. I have to shut down again. This is just a moment. Let me shut down. So yeah, go back to, I forgot to provide the script. I just remembered that I forgot to provide the script. Okay, so while that is loading, let's explain this side. So this is a common table expression. Most people just popularly refer to it as CTE, common table expression, right? So in a common table expression, you define a table just by providing a name. This is it with this, and then you define what data that table will store. So in other words, you can begin by stating your inner query, right? Just like the same step we use for a derived table. This is the inner query right here. So this is the same inner query. You see the parenthesis right here, closing right here. This is the inner query. Instead of providing the name of the inner query below using the AS keyword as this, for a CTE, we go above. This is the name right here. So the opening statement is with. We provide a name of this. You see, these are named queries. So this is a name we want to give to this query. And then previously, we now go to the outer above and build the parent. In this one, the outer statement is below. So you capture you build and store above, and you query the information that you've captured above. This is it. So this right here must always be the same as this. This is very important. So if we now go back to all the examples we've solved using the derived table, we can repeat all of those examples using the CTE by just changing this configuration. Right? It's going to be that same query we've captured inside. We instead go above and have this opening statement with we provide any name you want to provide right here. The AS keyword is there. And then once you've defined that, you go below and run another outer statement, which will pull the data you've captured in that named query above. The same name applies to this. You've captured something above and then you're processing it further below. See that? So all the questions we've solved using the derived table, you can go back to them and solve each with this new approach for a CTE. So this is something you should not forget. A CTE begins with the keyword with, followed by the name of the CTE, and then the definition of the query. After that, you go below and write an outer statement to further, apply logic on the data you've captured. This and this, same. See, let me see if I can run this. Right. So let me just pause right here so you can see the rearrangement of those key concepts. First concept, inner query. Second concept, give it a name. And then the last concept, introduce a parent or query it from an outer query. And the outer query in this sense is this. So you still see those three components. Inner query, give it a name. And then outer query from above. That's the steps for a derived table. For a CTE, the same three steps. Inner query, give it a name. And then query it from an outer query. This is the outer query right here. Right. So those three steps are still showing up. Right. Okay, let me load this page so we can address. So you're right here. The concept of duplicates, I will push them during the lab. How to delete duplicate rows. Those are applications of this concept. For today, I just want us to understand them. Right. And then subsequently, we're not going to see the applications in key business processes, like how to delete duplicate records from a table. In the data cleaning, they use CTEs a lot. So let's switch to common table expressions as what is popularly known as CTE. Right. Common table expressions. Right. So common table expression, CTE. A common table expression is similar concept to a derived table in the sense that it's a name table expression. You see this again. Name table expression. You have an expression which runs and has a name right here. You have another expression, in this case for a derived table, runs and has a name right here. So these are name queries. It's visible only to the statement that defines it. So like, I think I've demonstrated this. If you delete this statement that defines this, you render it useless. You need to see it together with the statement, right? And these are the three steps we talked about. Inner query is defined. I can show you on both sides. There's an inner query for the derived table. This is the inner query for the CTE. Step one. Step two, the name you assign to the query, right? So for a derived table, the name of the query follows directly below right here. But for a CTE, the name of the query is above right here. This is the name of this query, right? This is important so you see the different arrangement. Now, finally, the outer query. So this is what we call the parent query in a subquery. This is a parent, and then the subquery serves a child. In a CTE, the outer query is below, and it is querying data from the table you built above. So this and this must align. See, in all the CTEs examples, you're gonna see that. Right. Again, the steps are there. Right. I'm gonna skip this. If I want to run this, it's gonna take us a lot of time. Right. But anyway, I can still just explain. We solved this question above. We use the row number. You can use rank. Right. So this right here is what we are calling T1. Remember, in a CTE, you begin with the keyword with, you put the name of the CTE and the definition of the query. So we've defined this query. This is our inner query. We see the same parentheses are there, same picture you have for the derived table. The inner query is enclosed within a set of parentheses, open and close, inner query enclosed. The name of the inner query goes to the top for a CTE. See? So we're calling this T1. So you're saying with T1 defined as this, capture that information, then go below, that's the outer query, is now doing some other analytics on the T1 we've captured above. See that? So in a CTE, this name and this name must be aligned. If I just go here and put T2, I've distorted that query, right? Because I build T1 and I'm doing select from T2. Where is T2 coming from? So then the names have to align. You see, if I take it back to T1, right, everything is going to be fine. This, right? And that's when we can throw that logic in using, you see, right here. So we are going to T1 and we are only showing the most expensive product for each category where rank number equal to 1. Right. Let's follow through with this HR1. We solve this HR equation above where we're looking at the query that will give us the n highest salary at any given moment, and n was defined to be any of these numbers. Right. I think what I'm going to do is copy this right here. And next, I will push this on 2 windows. I want to try something. Select this and this, right click. Let's get a new horizontal, vertical tab. You see the arrangement? I want to have 2 tabs side by side, something like this. Now, on the left, I will show you the build process for a derived table, which is just going to be a revision. And on the right hand side, I will show you the build process for a CTE. We are all going to be using, I want to make sure I switch to the same, I set the same database. So use HR on the right hand side and use HR, right? How can we use the same? You see that? How can we use the same inner query and navigate our way first with the derived table, second with the CTE? So that is a query I put right here, right? Let's switch to a row number, right? Row number right here. So let's understand what it's doing. This is ranking employees. Are we doing any partition? No, no partition. This is ranking employees based on salary for the entire company. Since there's no partition, the numbers will be continuous. See, unique, sequential, continuous numbers. There are a total of 107 employees in the company. You can see the ranking all the way to 107. No partition by was used, right? And it's the same thing. I'm going to copy that query and paste it on this other side. And then we're going to do the transformation using the same query, transform this, right, into solve this question using the CTE, solve the same question using derived table. Remember, the goal of this question is to write a query which will give us at any time n highest number of salary, n the employee with the n highest salary, where n can be any number you plug in, right? So after capturing the ranking, you don't want to mess this, right? You want to preserve this query as the inner one. And then you go outside of this environment to do further analytics, right? So this is me. You see what I'm doing? I'm embracing or including the inner query in a set of parentheses, open and close. For a CTE, for a derived table, the AS keyword comes after. So the name of the CTE is right here. We're just going to call it T1. That is the first step you realize for a derived table, right? The positions of the inner query is the same across the two. It's in the middle, this right here, and then we have this right here. Same thing, see? Now, where the difference sets in, first, the position of the alias, the name of the query. This query is aliased into this table. This is a table alias. This is different from a column alias. What we are aliasing right here is a table. So this right here is a table alias, right? It's different from a column alias. So T1 is the name we've provided to this query. This query runs and generates a table called T1. This is our T1, right? You see that? So we've given the inner query a name. So we've done step 1 and step 2. What is the last step for a derived table? In fact, let me just go ahead and do it the same on this side. For this side, we're going to do the same. Enclose your inner query within a set of parentheses. Same thing I'm doing on this side. And if I go to the syntax guide right here, this is just what I've done. Enclose the inner query in a set of parentheses, open and close. The name of the CTE goes above, and you have to initiate that process with the keyword with. See, this is very important. Keyword with T1, I'm going to keep the same name, T1 as, this is very important. So my T1 is a table which is defined as this. So if you run this query, it returns a table. This is our T1. Right, this is very important. Right, I know these are things you can do. It's just a change on the syntax. Right, so we've done that part. Now the last thing to do is what? The outer query. Let's go back to the syntax. Well, the outer query in a derived table is placed above. So go to your derived table and do your select star from above. This is me putting the outer query in the construct of a derived of a subquery. This is the parent. See, select star from that. That's all. That's the outer query. And if you need to involve a condition on the outer query, you just go below and put from, where, group by if you're grouping and stuff like that. But so far so good. This is the structure of a CTE. No condition has been added to the outer query, so we are still keeping the same results we had from the inner one. In this case, what do? This select star we've put right here goes below. This right here, it goes below, and the from should carry the name of the query you built above. So if you're putting this below, you get select star from what? T1. The name right here should correspond. Let me just type T1 right there. And that's the framework right there. With T1 defined as this, now give me select everything from T1. So you build above and then you run a query against what you built above. Right, see that? And now we can start making this interesting by using, let me just go to this, that alias, which is a ranking, and say where. So this is me targeting now the outer query or the parent and putting this condition so that we don't get all the rows, we get only the specific ones we've requested. If I put this equal to 10, this is the employee with the 10th highest salary. This is the process being achieved using a derived table. Right. For this, you simply put the where clause right here, where the rank, that's the column, equal 10. That's the same approach right here. And when I run this with the CTE, I get that same result. Let me run this side by side so that you see. right? Same, right? This is very, very powerful, right? So all those exercises we've solved using a derived table, you can now go back and solve them using a CT. And yeah, and that's the end of today's lecture. Right, let me just dismiss this. Please, if you have two windows and you want to, you can just right click on the second one and go to this option. Let me dismiss all of this. Anyway, before I dismiss this, any question, let's address. So I was just, and now these two are working independently. When you click on this one, you work on it. Click on this one, you work. See? This helps you to view things side by side. Right. So this is important. Any question? Yeah, I think we can even end the lecture right here. The most important things for you to understand is I don't want to go any further. I want to give you time to understand this before we now look at the applications of the process, like in deleting duplicate records in the table. Right. Any question on this? Let me
Not from me. But I got one question actually.
okay, question, yeah.
So if you were to say like what's the biggest difference between a city and a derived table is kind of like the placement of like the sub and the inner query kind of, or
Yeah. And then one other thing, yeah, but if you have that kind of question in an interview, they expect more from just the syntax arrangement. For example, if you notice in a CTE, you cannot place the CTE in the where clause. Now, because when you're talking about the bundle, usually the question is subquery versus CTE. If you look at, let me take you back to that Facebook stuff, subquery versus CTE. But now you understand that in the subquery, they are referring to a derived table, right? So in the subquery, you're targeting a derived table, this conversation right here, right? CTE subquery, but then the subquery is, right, so CTE subquery. A subquery can be placed in the where clause, right? A CTE, you just simply build it. I will give you this document and basically this one as well. Everything I want to explain is in this. Let me just show this document right here. This one, no, not this one. This is just the explanations. Yeah, this is the point I was making. The subquery, you can actually put, we've seen three locations of a subquery. The column to generate, and the select to generate the column. We've seen in the where clause, and then we've seen in the from clause. Right, and that's one very key thing you can mention. What's the difference between a subquery and a CTE? Subqueries can be placed in a where clause. You notice that when you define a CTE, let me just go back to this. When you define a CTE, right, it's basically a table you've created. This is it. All of this definition right here is storing this information into this. And then when you go to the outer query, you're limited only to what? Since the table, that's it, the from. Right. But then this is targeting this subquery. You can also take it and put it in a select to define a column. You can put it on the where clause to define a condition. All right, so this one has a lot of flexibility. But now let me talk about this from an optimization perspective. Most people advocate the use of a city. It has a better performance in terms of optimization. The query it runs faster than a subquery. Right. So this is much more better optimized than a subquery. Right. So if query optimization is a goal to focus on, then most people always advocate that CTEs perform better than subqueries from a query optimization point of view. Right. And I'll also refer you, I'll also encourage you to create time and go over this you're going to see a couple of this person made a great advantages of using CTE, right? Yeah, and this issue keeps showing up. Choose a subquery when you're using the where clause. If the goal is to take this subquery and incorporate it as a condition, right? This is excellent. Go through a subquery and put that in the where clause. But once you build your CTE, right, you cannot take that information and try to process it in a where clause. Right? Where is that? This one right here. You see, this is built. It actually is a table. Right? That information cannot be placed further in a where clause. But you can actually take this you build, and instead of putting on the from clause, you actually decide to put it. You know what? I'll put it on a where clause. That is supported. Right? And also remember, in the query optimization, this works better than this one. This is much more efficient, much more faster than this one. And also in a CTE, you can define this and use it across multiple queries. This one, once you've defined this, you can only use it right here. Right. And let me show you something. There's also further nesting. Let me do this. Do a select star from, just dismiss this one. Let me copy this right here. I'm going to put it on a new query window. Usually when I start opening more query windows, that's when these things are performing slowly. I'll remove this. I want you guys to see something, right? So when you're going above, it's not only limited to one time. I don't know if you guys have been able to visualize this process. Let me indent this. Of course, it's already indented like this. So this is one time we've gone above, right? I can now take this to be my new sub one, everything, 2, and I call this as T2, for example, right? T2. Please stay with me on this. And this is the second time I'm going above. And then I go above. This is the second time. Select star from what? T2. This is valid. If I run it, it's going to execute. So in my first, I extract 5 out of the 107, right? And then I can now bring in another where clause for T2 to show me just the first 2. See? And you can keep going, outside. You can bundle this again, and then you see. So let me go all the way to the inner one. The inner one is my T1. The inner, this runs T1 gives you everything. 107. Right? I just want to expose you to a certain logic. 107. Right? The inner one is only accessible to this one. Only this can access this. So all the columns we've defined right here in T1, they can only be exposed to the parent query directly above it. So let me try to draw this out. It's like you have a first circle, it builds something. The second circle outside assesses what is in the inner one. Then as you keep going outside, we have this. See? So my T1 is right here. I access this T2, and then I go outside. You see, that's basically what I'm doing right here. So once you build this query, the columns of that can only be accessed by the query directly above it. I cannot be at T3 and I'm trying to access a column that was built in T1. T3 can only access what is retrieved by T2. T2 can only access what is retrieved or returned by T1. That's a serious limitation. But in a CTE, you can build and use. There's no restriction to that. I think during the lab session, I'll try and come up with something to further illustrate this point, right? But then you understand this. This is T1. T1 is basically this query. So to access this, you have to go to the innermost part. Innermost, this is what you're getting. See that? And then in this innermost one, yes, I can access all the columns. You see, this is a direct outer query to this innermost one. It has access 1, 2, 3, 4, 5 columns. All right, let me restrict these columns to what? Give me the rank as a column. Give me the employee ID. See, I'm only limited to those columns that were pushed by out by T1. Employee ID. See, what I'm typing them, the department, right? Department. I'm going to stop right here. Department name. I have pushed out. I've dismissed the salary. See. Now, this is now my T2. See what T2 shows me. Every column except the salary that I dismissed. Right. So you cannot now come from the outer one, this one, and you want to extract salary. Salary is no longer accessible because salary was kicked out from the second level of the outer query. So this outer one can only access the things that are stored in T2. This is my output for T2. Salary was kicked out when I listed the T2 columns. Salary was kicked out. Now the parent query for the last parent query no longer have access to T1. But in a CTE, each time you define this, you have access to all the information. I can use it right here and use it again subsequently. That's it called a recursive behavior. When you read this article, you'll see that. Right. So this is very important. Just a moment. Let me see. I used to have a diagram that demonstrates that process. Oh, I don't think I have. Yeah, right here. So the query one, I'm going to give you this I think during the lab or the revision week. Query one, the query two can only access the columns that were pushed out by query one. By the time you're going to query three, you can only access the columns that were pushed out in query two. So you cannot be in query three and you're trying to locate the columns that were in query one. No, it doesn't work like that for subqueries, right? And you can keep going outward. If I stay right here again, I bundle this, just follow the steps, bundle this, I give it a name. See, call this T3. We have T3, T2, T1. That's all. And then you go out now and build the query. This is now select. All right, so for example, let's say, anyway, let me just build this select star from, see, and I run this. I want to make a process where I keep reducing the number of columns as I'm going outward. Let's go to the innermost one. The innermost one is where everything began. If you look at this circle, the innermost one, this is where everything began, right? So let's access the innermost query. This is our T1. That's where everything began. Run the query for T1. This, please take note, to run this query, you cannot run like this with the parentheses and the alias. It's not built like that. See, you're running a select statement. So the select goes from select from and ends right there. The idea of including the parentheses as just distraction is the concept of building the outer query where that becomes useful. But if you just want to isolate the innermost query and run it, this is select statement. So you're running the things you can identify within the select statement. Right? I see people bundling things like this and executing. No, it doesn't work. You can think you can do this. The parentheses will just show up there, but not the alias. This will run, you see. So better still, I always just prefer to identify just what I know my select statement is all about and execute. I get the full picture. You see, all right. Now in the outer one, I've dropped salary. So I'm giving rank, employee ID, department, I've dropped salary. See, that's why if I now go to the outer one, this one, and I run it all the way to this, I don't get salary. In the next one, I'm going to drop department. Right. So in the next one, I'm going to take rank and employee ID. I drop department. Because I'm going outward, I'm dropping. In this one, this is it. At this phase, if I stop right here and run it, this goes all the way to, I'm now at the T2 level with this condition on T2, execute. You see, I cannot access salary. You see, I cannot come right here and say, hey, give me salary. Salary is not identified. Salary is something that came in the innermost one. You cannot be on Q3 and you're trying to access a column that was pushed out in Q1. For you to access that, you have to keep it showing up in every other parent statement onto the top. This is a serious limitation with the derived table. Right? The outer query is only accessible to the innermost outcome. So if you're on this query 2, the results you can track on this is only limited to what query 1 is showing. Right? And that's how this becomes complicated as you're going outside and you're getting more limitations. Right? So I cannot get salary, I cannot get department. If I try to bring department right here, paste it, it gives me an error. Now, I think we're going to see that on the other one. We have to go outside. So outside now, where are we? We are right here. Let me just remove this comma. So I'm building a scenario where as I'm going upwards, I'm dropping one column. Right. So now we're in this right here. When you see an invalid stuff, it means that the portion highlighted. So I'm doing select this from this. That's why indenting helps actually. This is T2. Yes, T2, and the condition on T2 is this. Yes, this is my T2 right here. Execute. All right. So if I go to this, I will have access to rank and employee ID. True. That's true. I no longer have access to what? The department name. See, it flags an error. I no longer have, at this level, I don't have access to salary because salary was dropped. See, I don't have salary. So as you're going higher and you're dropping columns, you don't have access to those columns anymore, right? So at this point, I only have access to what the immediate query below give to me. See, you have to understand this circle right here. You cannot be on query 3 and you're trying to access a column that was pushed out in query 1, but was dropped in query 2. And so on. You see, as you're going out, if you want to keep returning all columns, you have to keep you have to maintain the columns as you're going outward. Let me back out of this. So I was missing a from right here, and this is ID. See, we've been going outward, and there's a full picture. See, and in this outer one, I can then bring its own condition and say, hey, finally give me the highest, where this equal one or in one. Like the in operator can search one value as well. See, but see where we started. We started with an inner one. This C1 is giving us all the 107 employees. In T2, we narrow it down to 5. This is T2. We narrow it down to 5. We get this. See? And then brought in 3 T3, which gave us just 1 and 2. Right? And then the next final one came in, and that's T3, which gave us just 1. And that's, and you can keep extending outward. And the only thing you have to remember is, hey, if this is the query you want to bundle and return, it's possible you can just get this off. Oops, no. Highlight everything, Control A, Control X, and then you just build that query. Select star from. Of course, remember this environment will always be there, open and close, and then give it a name as final, maybe. Right, and then paste that query inside there. The more it's becoming complicated, that's what can guide you. Extract, build. See if I just do this. This is the skeleton of it, and then the query goes right here. See, paste that. Now you can run it. See, how many times have I gone outward? Serious number of times. From the innermost you're tracking, see, and this circular arrangement can guide you. And also for a CTE, you can build the first, put a comma and build. You can build multiple, right? So you can go back to all those questions we've solved. And for example, this is the customer ratings one, the credit rating, the TransUnion database project one. This is a CTE. We build this query, package it into an inner query. This is where we started off by using a case statement to investigate the rating of each customer based on their credit score. This is what we had. Remember that, oops, select this. I forgot the from clause, this to this. So we have 2 columns right here. Right. So we now define this as what? With this, so this table will be stored under what? Customer ratings. With this define as this, go further now and do that calculation of counting the number of customers in each credit rating. And this always make sure that this is the same as this. The table you've captured above, you're using that same table to do further processing. And that's just the foundation of this concept of CTE. And you can define a CTE like this, put a comma and define another one. Right. For example, let me copy this. Let's open a new query window. This is a CTE I've defined right here called customer ratings. Call this one customer ratings. Right. All I need is just one with. When I define this one with that, I can put a comma and define another one. And then end up using both of them. Right. So you can define multiple CTEs, or using one with this define as that. You define it, so I think I put that comma in the wrong spot. It should be enclosed in this with a comma, and you define the next one. right? The next CTE, and that's how this. So the first CTE is defined. You put a comma. Second CTE is defined. Right? Then during the lab session, I'll come up with an example on that, so you can explore. Yeah, yeah. I'm going to end right here so that we limit the knowledge to the focus on this tool right here. I'll give you time to play around with the syntax, so that by the lab session on Wednesday, we have a good mastery of the tool. Then now we can explore those business applications of this process, like deletion of duplicate records. So the next part of the notes that are right here with regards to that process, how to delete duplicate rows. See this, right? Duplicate data. All of those are just the same kind of concept, right? Okay, any question before we go? So what's the focus of tomorrow? Tomorrow, I'm going to talk about set operators. This is popular in interview. What's the difference between union and union, or interviews like asking that question? And then I've pushed forward this concept of variables to this. We're going to use variables in user-defined functions. So we're going to definitely talk about them tomorrow. Before we get, what are user-defined functions? You can define your own function. Of all the functions we've seen provided by Microsoft, if those functions don't help you, how can you build your own function? Or how can you take a formula that is used every now and then by company, and then you say, you know what, I want to transform this formula into a calculation, a function. And that's what we call a user-defined function. So you can build your own functions in SQL 7, right? So that's what we're going to look at. That's the focus for tomorrow, right? And then next week, I think that's when we're going to do the project week. But I'm going to keep you updated on that. That should be our last week. So it's going to be a project. I will show you how to create databases, create tables, insert data into tables, and then we're going to do some other projects. Now we can do the solving of the equations based on the databases we've built. Right. So tomorrow, set operators, variables, user-defined functions. Those are the three topics we're going to cover tomorrow. Right. So while you explore these two concepts we've studied today, we're going to see more projects during the lab, just playing around these two concepts. Right. Okay. Any question before we go?
All good on my side.
Okay. Awesome. Tunde, are we okay? Looks like Tunde, your microphone is muted. Okay, guys. See you tomorrow. Yeah, we're gonna continue building these concepts tomorrow. See you all tomorrow. Have a nice weekend.
Yeah, thanks for today. See you tomorrow.
See you tomorrow. Yeah.